Hi, hello, welcome to VHDL Basics. Today I am going to take top 5 digital electronics interview question from ChatGPT and then I will try to explain each questions in this video. So here I am asking top 5 digital electronics question in VLSI. So this is the first question. What is mean by digital electronics and how it is used in VLSI design? Digital electronics refers to the branch of electronics that deals with the design and application of digital circuit, which use digital signals instead of analog signals to represent and manipulate information. Digital circuits are composed of electronic components such as transistor, logic gates, and memory cells, which are used to perform operations on digital signals. VLSI, very large scale integration design, is a field of electronics engineering that deals with the design and manufacturing of integrated circuit, that is ICs, with the large number of transistor and other components on the single chip. Digital electronics is an essential part of VLSI design as it provides the building blocks for digital circuit that are integrated into the ICs. Digital electronics is used in VLSI design to create digital logic circuits such as adder, multiplier, flip-flops, and other components that are combined to create larger digital systems. These circuits are designed using hardware description languages such as VHDL and Verilog, which are used to specify the behavior of circuit in terms of its input and output. Once the HDL code is written, it is synthesized into a netlist, which is representation of the circuit in terms of its logic gates and other components. This netlist is then optimized and mapped into physical location on the chip using tools such as logic synthesis and place and route algorithms. The resulting design is then verified using simulation tool to ensure that it meets the desired functionality and performance requirement. Overall, digital electronics plays a crucial role in VLSI design by providing the functional building blocks for di- digital circuits that are integrated into ICs, enabling the creation of increasingly complex and powerful electronic system. Now, moving to the second question, what are the various logic families used in VLSI design and how do they differ from each other? There are several logic families used in VLSI design. Each family has its own set of characteristics that makes it suitable for certain applications. Some of the most commonly used logic families are TTL, transistor logic. TTL is popularly logic family that is known for its high speed and low power consumption. It is commonly used in applications such as digital signal processing, microprocessor, and memory circuits. Next one, CMOS, complementary metal oxide semiconductor. CMOS is another popular logic family that is known for its low power consumption and high noise immunity. It is commonly used in applications such as microprocessor, memory circuits, and other signal processing. Next one, ECL, emitter coupled logic. ECL is a high-speed logic family that is commonly used in applications that require extremely fast switching speed, such as telecommunications and high-speed data processing. Next one, RTL, resistor transistor logic. RTL is a logic family that is known for its simplicity and low cost. It is commonly used in applications that require basic logic functions such as in calculators and other control circuits. Next one, DTL, diode transistor logic. DTL is logic family that is similar to RTL but uses diodes in addition to the transistors. It is commonly used in application that requires basic logic function such as calculator and simple control circuits. Next one, MSI, medium scale integration. MSI is logic family that combines TTL and MSI technologies. It is commonly used in application that requires complex logic functions such as in microprocessor and memory circuits. The various logic families differs from each other in terms of speed, power consumption, noise immunity, complexity, and cost. Choosing the right logic family for the particular application depends on a variety of factors, including required speed, power consumption, noise immunity, and cost constraint. Moving to the next question, explain the working principle of flip-flops and latches and how they are used in VLSI design. Flip-flops and latches are two types of sequential logic design logic circuits used in digital electronics and VLSI design. Both are used to store a binary value 0 or 1 and hold it until it is changed by an input signal. The working principle of latch is based on the concept of feedback. A latch circuit consists of two cross-coupled NAND or NOR gates, and it is used to hold a value until a new input signal changes it. The latch has two stable states, set and reset. When the set input is high, the output of first of the gate becomes high, which causes the output of other gates to become low. This in turn reinforces the high output of the first gate, and latch remains in the set state until the reset input is high. Flip-flops are more sophisticated than the latch and are widely used in VLSI design. The most common type flip-flop is the D flip-flop, which has data input D, clock input, and two outputs Q and Q bar. The flip-flop stores the input value D when clock signal goes from low to high, and stores the value is held until the next clock edge. The output of the flip-flop is stored value Q and its complement Q bar. There are also other type of flip-flops such as JK, SR, and T flip-flops. Flip-flops are used in VLSI design to store digital data, register values, and implement sequential logic circuits such as counter, shift register, and state machine. There are two. There are also used to synchronize signals in complex design system and prevent data loss due to the timing problems. Latches, on the other hand, are used in simpler digital systems such as memory element and input or output buffers. Moving to the fourth question, how does the clock distribution network work in VLSI design, and what are the different types of clock distribution networks used? In VLSI design, clock distribution network is responsible for delivering the stable and accurate clock signal to all the synchronous element of the chip. The main function of clock distribution network is to ensure that all the register and flip-flops in the design receives the clock signal at the same time and with minimum skew. The clock distribution network typically consists of a series of buffer stages, and that helps to amplify the clock signal and minimize any signal attenuation due to the long interconnects. The clock distribution network also includes various clock routing techniques to maintain the integrity of clock signal and minimize the timing issues such as clock skew and jitter. There are several types of clock distribution network used in VLSI design. I am going to explain some of them. Tree-based clock distribution network. In this type of network, the clock signal is distributed from a central point to all the synchronous element in the design in a tree-like structure. The main advantage of this type of network is its simplicity, but it may not be suitable for large design due to long interconnect and high capacitance. Next one, tree clock distribution network. This type of network is similar to tree-based network, but it uses the hierarchical structure of distribute the clock signal. The clock signal is divided into smaller branch at each level of hierarchy, reducing the capacity and minimizing the delay. Grid-based clock distribution network. This type of network uses a grid-like structure to distribute the clock signal to all the synchronous element in the design. The clock signal is delivered to each element through a combination of horizontal and vertical wires. This type of network is suitable for design which high number of synchronous element, but it may be complex to implement. Mesh-based clock distribution network. This type of network is similar to grid-based network, but it uses the mesh-like structure to distribute the clock signal. Clock signal is delivered to each element through a combination of diagonal, horizontal, and vertical wires. This type of network is suitable for design with high number of synchronous element and can minimize the skew and delay between elements. Choice of clock distribution network depends on the size and complexity of the design as well as the timing and power requirements. Last question of the video. What is mean by power dissipation in digital circuit and how is it minimized in VLSI design? Power dissipation in digital circuit refers to the amount of energy that is consumed or lost as heat when electronic devices such as transistor, logic gates, and interconnects switch on and off during the operation of digital system. In VLSI design, where circuits can contain million or even billion of transistors, power dissipation can become a significant problem that affect both performance and reliability. There are several ways to minimize power dissipation in VLSI design. Some of them I'm going to explain now. Use low power design techniques. These techniques includes clock gating, power gating, and voltage scaling, which helps reduce the power consumption during ideal period and in parts of the circuit that are not needed. Optimize circuit architecture. Architecture plays a significant role in power consumption. By choosing an efficient circuit architecture, the number of transistors can be minimized and number of active devices reduced, thus increasing power consumption. Use low power device. Choosing device with low power consumption and such as those with smaller feature size can significantly reduce power dissipation. Optimize interconnects. Interconnects are the significant source of power dissipation in VLSI design. By reducing their length with resistance, power dissipation can be minimized. Optimize system level power management. At the system level, power management techniques such as dynamic voltage frequency scaling and dynamic power management can help minimize the power consumption during the operation. Overall, minimizing the power dissipation is a critical consideration in VLSI design, and various techniques can be employed to achieve this goal. Hope this will helpful for your next interview. Thanks for watching this video. Please like and share this video. Subscribe this channel for more videos.